Metadata filtering is how a RAG system narrows down a huge pile of documents before it even starts comparing meaning. In this video, we'll cover three things: why similarity search alone isn't enough, how metadata filtering actually works under the hood, and how to combine it with vector search to get results that are both relevant and correct. Welcome to Scovia Labs, where we turn AI ideas into everyday intuition. Let's start with a quick recap of how RAG works. You take a user's question, convert it into an embedding, and search a vector database for chunks of text with similar embeddings. Those chunks get stuffed into the prompt, and the model answers using them. If you're unfamiliar with embeddings or vector search, check out our videos explaining it. Links in the description. So this RAG framework works great until your document collection gets big and messy. Picture a company with 10 years of internal documents, like HR policies, engineering specs, legal contracts, old Slack exports, you name it. A user asks, "What's our current parental leave policy?" Pure similarity search doesn't know what current means. It just finds text that sounds like parental leave. So it might pull back the 2019 policy, the 2022 draft that never got approved, and a slide deck from a town hall 3 years ago. All because they are semantically close to the question. The embeddings aren't wrong, they're just blind to things like date, department, document status, or access level. That's the gap metadata filtering closes. Let's use one running example. A company knowledge base with HR, engineering, legal documents, each tagged with a department, a date, and a status. Metadata is just structured information about a document, sitting alongside the actual text. Think of it like the label on a filing cabinet drawer. It doesn't tell you what's inside the folder, but it tells you which drawer to even open. Here's the step-by-step flow. Step 1 is tagging documents at ingestion time. Before anything gets embedded, each chunk gets tagged with attributes, like department is HR or status is approved, the date associated with it, and this happens once when you load documents into the system. Step 2 is the user's question gets parsed for filter signals. When someone asks, "What's our current parental leave policy?" a well-built RAG system recognizes current as a signal to filter by status being approved and prefer a recent date. This can be done with simple rules or by asking the LLM itself to extract filters from the question. Step 3 is that filtering happens before the similarity search, not after. This is the part that people get backwards. You don't run similarity search across everything and then throw out the bad matches. You first shrink the candidate pool down to documents matching things like department being NHR and status being approved, etc. And only then you run the embedding comparison on the smaller, cleaner set. Step 4 is that similarity search runs on the filtered subset. Now the vector search is comparing the question against, say, 12 approved HR documents instead of 10,000 mixed documents. The same embedding math runs, it's just operating on a much more relevant haystack. Step 5 is that the top results get passed to the model, and the model now sees only the 2026 approved parental leave policy, not three contradictory versions from different years. This is basically how a librarian works. Not a search engine that reads every book, right? So a librarian doesn't reread every book in the building to answer your question. They first walk you to the right section, like fiction or mystery, and then to the right shelf, and only then they start scanning the titles. A natural question here is, why not just stuff every possible signal into the embedding itself instead of using separate metadata? Well, you could try, but embeddings are built to capture meaning, not exact structured facts. An embedding model might sort of associate 2026 with recency, but it has no guarantee of treating dates, statuses, or department names as hard constraints. Metadata filters are exact and deterministic. Either a document is tagged approved or it isn't. There's no fuzziness. That precision is the whole point. Vector search is good at finding things that mean something similar. Metadata filtering is good at finding things that satisfy this exact rule. You need both because meaning and structure are different problems. And there's a cost side too. Filtering too aggressively can backfire. If your filters are too narrow or the metadata tags are wrong or missing, that might result in you filtering out the one document that actually had the answer. So, metadata quality at ingestion time matters just as much as the filtering logic. Metadata filtering is not a replacement for vector search, and it's not a substitute for good document hygiene. It doesn't understand meaning. A filter can tell you which HR policy is most relevant to a vague question. That's still the embedding's job. The filter just decides which documents are even allowed into the contest. And it can't fix bad metadata. If nobody ever updated the status field when the 2022 draft got rejected, filtering by status being equal to approved won't save you. Garbage tags in and garbage filtering out. So the real trade off is this: metadata filtering decides what's allowed to be considered. Vector search finds what sounds right, and a production RAG system needs both working together, not just one instead of the other. I hope this helped you see RAG search as more than just embeddings doing all the work. Please subscribe to Scovia Labs for more eye opening AI insights, and as always, stay curious.